Hello. In this video, we're going to go into a brief introduction into array lists. We're going to look really at them from a functional standpoint, as in how do I use them in my program. We'll talk about some theory, some of the underlying principles with them, but mostly we're interested in how do we use them. So let's just really do a quick review of what a data structure is. A data structure is a programming structure that allows programmers to store collections of information. There's lots of them out there. I do strongly suggest you go out on the internet and do a Google search for data structures and do some reading. They're quite interesting and they'll be useful to you if you continue to program. So we have two broad categories of data structures. We have what's called a static data structure and a dynamic data structure. A static data structure is one whose size has to be set and it can't be changed. So an array is a static data structure because we have to set the size of the array before we start using it. Now, you can do things that make it appear like the size of the array is changing, but it isn't. What's happening is you're creating a whole new array and you're copying information over to it. A dynamic data structure is a data structure whose size can change during runtime. And an array list is a dynamic data structure. So let's start off with some essentials. So an array list can be thought of as an array whose size can change. For all intents and purposes, we can envision it that way. As elements are added to an array list, the size changes. This also means the indexes change, so watch that. It's particularly important with an array list that we use the built-in method to calculate the size whenever we need to know that. An array list is made up of reference types. So this is critical here. You can only make an array list that contains reference types. So if you want to create an array list of integers, you need to use the integer class. You cannot make an array list of small ints. You can only make an array list of integers. Okay. For all intents and purposes, they work the same, and Java has some nice little features where it manages if you try and give an array list of integers an int. But it's critical that you understand you can only make an array list of reference types. So these are some examples of how we would declare and initialize an array list. When we initialize an array list, nothing's in it. And the first one is an array list of fraction objects. The second one is an array list of scanner objects. And the third one is an array list of double objects. Notice double with a capital D. So we have a primitive type called double. But in order to make an array list of type doubles, they have to be reference variables. And again, I've repeated that down below. So with array lists, we use instance methods to manipulate them. You want to familiarize yourself with the ArrayList documentation. In a minute, I'll pull that up. Here are some key methods that are good to know. We have add, remove, size, set, get. But again, there's lots of them. Don't bother trying to memorize them. Familiarize yourself with where you find the information online. So you might ask yourself, what is E? For our purposes right now, you can think of E simply as representing the object type that the array list consists of. So if I have an array list of integers and I want to add an integer, I want to add an element, I'm adding an integer object. If I have an array list of scanners and I want to add a new object, I'm going to add a scanner object. So E right now is a generalization of the object that is contained in the array list. And again, don't try and memorize all of them. You'll remember them with time and practice. Really important you know how to read the documentation. And if you happen to be running the AP exam, make sure you take a look at that documentation in advance of going into it. You shouldn't be taking time in the AP exam kind of thinking, oh, where do I find this information? So here's the ArrayList documentation I was talking about. You can find this by doing a Google search for ArrayList Java. I suggest putting ArrayList Java 8 because Java 8 is currently the most current version. And if we scroll down, again, there's a whole bunch of information here. Don't be intimidated by this. Learn how to read what you need at this point, and over time you'll become more and more familiar with this documentation. And here's the list of our different methods. We'll jump back and look at this as we continue on in our presentation here. So let's just do a quick example and trace the code here. So if I write this line, what I'm doing is I'm creating an array list of integers. Initially, there's nothing in the list, so it's an empty array list of integers. So if I say list.add1, what that does is it uses the add method. And if I take a look in here, let's jump back to our documentation. There's our add method. So it's taking a single parameter of type integer, and then it adds it to the list. Now you might say to yourself, well, wait a second, this is one, isn't this an int, meaning a primitive type? It is, but Java does have some nice little features that it will account for this. So it will convert this to an integer from an int for us. So when this line's done, we have the number 1. If we then say list.add2, it adds it to the end of the list. So our list contains 1, 2. So our list has a size of 2, index is 0, 1. List add 3, 1, 2, 3. So the remove method, it removes a specific value. So if I say list remove 1, let's jump in here, let's look at the documentation. So I'm going to scroll down, I'm going to find the remove method, and I'm going to ask myself, so here there's 2 versions of remove. So remove is an overloaded method. One version takes an int, the other version takes an object. So we look at our example and we see that we're passing it an integer. So that means I'm using this version of remove. So it's going to remove the element at index, whatever index I pass it. Take a note here, return something, but we'll talk about that a little later. So index is 0, 1, 2. So when I execute this line, we remove the index, the value at index 1. That space here is purely just a typo. So the question I have for you is, how do I remove the number 3 with one line of code, assuming I don't know the index? So if we take a look at this documentation, you'll notice there's another version of remove, and this remove takes an object. So if I pass the remove method an object 3, so an integer 3, then it will remove it. But the problem is that if I put a 3 like this, it's using this version of remove, which would in fact give us an index out of bounds. So in this case, I have to actually construct the integer. So list.remove new integer 3. And that's going to use the version of remove that takes an object and remove the first instance that it sees of the number 3. Okay, so here, remove is an overloaded method. Java knows which version to use based on the parameter. By using the integer constructor to create an integer object, the version that takes an object will be used. This version seeks out the first instance in the structure and removes it. Let's trace some more code. So let's assume we start from this line. What if I use this? So again, I'm hoping now you're starting to get into that rhythm of, oh, let's check the documentation. Let's scroll up, add. Well, there's a version of add that takes an index and an element. So it's going to add at this index that element. So what it does is it's going to take an index 1, is going to shift all the other elements from 1 over, make a space and put it in there. So we get 1, 9, 2, 3. List.set. Again, what set does is set will take this specific index and set the value to that. So set overwrites, so it's not going to make my array list any larger. It's going to take whatever is in index 2 and get rid of it and replace it with 12. So we see here 0, 1, 2. It's going to replace 2 with 12. So I had to trim the size here because it's to kind of illustrate a little idea here. This is actually going to have no impact on the list. An array list, when it actually gets created, what's happening in the background is it's actually creating an array of 10 elements. So if I have 3 objects in there, there's 10 actual memory spaces reserved. And trim to size simply cuts off any elements that aren't being used. So it has no apparent impact. You'll never really use it. But it's just a nice little one to do a little read about you might come across, especially if you're trying to optimize something for memory usage. Because the way an array list works is that each time you add an element is filling up that array that you don't see, and then when you fill that up, it actually just creates a number of new spaces. It doesn't each time create a new space. So it's a nice little one to keep in the back of your head. You won't see that on the AP. So list.add 9 is going to add a 9 to the end. So we're going to work at this one from the inside out. index of finds the index of that element. So we see 12 is at index 0, 1, 2, and then it adds it to the end of the list. And then we want to remove 9, and again, this version of remove that takes an object is going to find the first instance of 9, there it is, and pull it out. So below is the code segment that will remove all 2's from a given array list of integers. This is a pretty common kind of algorithm that you need to know how to do. So my first question is for you. Oh, pardon me. Let's highlight this point here. To calculate the size of an array list, we use the size method. We don't use .length, we use .size. So would this work if the list contained 1, 2, 3, 2? Would this work if the list contained 1, 2, 2, 3? So let's take a look. So what happens with this little code segment is essentially, I'm going to come into my loop, I is 0 and the size is 4, and the first element is not 2, so I move forward. The second element is 2, where I is 1 and size is 4, so it removes it. Did you see what happened there? When I remove it, the indexes change because the size gets smaller. So that 3 actually gets skipped. So I go, even though the 3, might think we look at it, we skip it all together. So now we remove that last 2, and we're done. So in this situation, this works, but only by chance. This is purely luck that this happened to work. So my question for you is, when would this fail? And this would fail if we had 2 elements that we need to remove placed right next to each other, right? Because remember, we remove that, and when that removes, all the indexes get shifted. So we skip the 3. So let's look. So here's a case where it would actually fail. So we're going to look here. I is 0, size is 4. We're going to remove this value. And see, we skip that other 2. And it fails. So we want to talk about best practices when we're using loops in array lists. And removing elements shift the index and change the size of the array list. So therefore, searching array list from indexes 0 to the list.size minus 1, which is the last index, can result in elements being missed. So one way to solve this problem is to simply step your counter back when you remove an element. So if I remove an element, I'm going to subtract 1 from I. Right there. And it's good to be familiar with all these shorthands, especially if you're writing the AP exam. However, if you work through the array list backwards, you avoid this problem. And this is the best practice. If you're searching an array list with the intent of removing elements, start at the end and work to the start, work to the beginning. And this is why. Watch. I is 3, size is 4. So we're going to remove this element and watch what happens. The only element whose index changes is the ones we've already inspected. So we actually go to that next 2 and we remove that. So if you have some sort of algorithm that requires you to remove an element, it's a good practice to start at the end and go to the start. So let's talk quickly about the remove method, because this is a little piece of the puzzle that people often miss, and it's such that it actually removes, when we remove an element, it actually returns that element we've removed. So a common question could be something like this. You have an array of characters, an array list of characters, and I want to remove all the characters and copy them into a string called vowels, right? Here's an implementation. So again, let's just kind of trace through this. Array lists are constructed with reference types, so I have to make my array list characters, not chars. And again, a good practice here is, because I might remove an element, I'm going to go from the end of the list to the start. That means I don't have to deal with I don't have to worry about the shifting indexes. So I could write a conditional statement here. You know, is it capital A or small a or capital E or small e? That's really long, so I just made a Boolean method called isVowel, which passes the object and then returns true or false. Boolean methods are always start with is or has, and there's the code down there if you want to see it. Okay. And now we get to the kind of point of this slide here, is this technique works. So the first thing I do is, if it is a vowel, I take the element, I get it, and I add it to my string vowels, and then I remove the object. But since the remove method actually returns the value you've removed, you can actually do this in one line. So it's a nice little feature to keep in mind. It helps optimize your code. So I hope that video helped. ArrayLists are a very powerful and useful structure, specifically when reading from files whose size you don't know. And if you have any questions, please don't hesitate to post them or ask me. P.S. ArrayLists have a nice 2-string method. You might want to check it. I hope this helped.